Hello, my name is Huldar. I'm doing my homework number 4 for Mechatronics 2, Spring 2025, and I'm doing part B here where I'm supposed to design, code and test a program in C that turns LED on and off slowly, fading, gradually increasing the light intensity using delay functions. And I'm supposed to describe the method used. So, I'm using a SAM D21 processor. This specifically is the SAM D21. Hold on, I have this specific one here. I have the SAM D21 G18A. That's the processor that I'm using. So it's this one here. And here is my delay file where I explain how the delay works. I made the delay that I made 3 delay functions. One of them delays in seconds, where you put in the number of seconds. The other one delays in milliseconds, and the third one in microseconds. Each time you run the delay function, it starts by getting the frequency with this get oscillator frequency function, which just checks which oscillators are running, and currently I only have it set up for the 8 megahertz oscillator, so it could not detect any other oscillators, only the 8 megahertz one, because that's the one that I'm using. I just have to implement the other ones when and if I need them. So that's the one that I'm using. And what the function does is that it waits for a number of cycles, which is how many seconds multiplied by the frequency, which works out because frequency is 1 over second, number of seconds, so the seconds cancel out. And in the wait cycles, you put in the number of cycles, it waits for the number of cycles. Each loop on this for loop here takes 2 clock cycles on the processor. So if however many clock cycles you need to wait, you have the number for the loops, and this is why when I get the frequency, I deliver half of the frequency. So the 8 megahertz oscillator returns 4 megahertz because it's half. That way I don't have to do any extra arithmetics where I have to divide by 2 or something like this. No arithmetics. It's just which oscillator, and it tells you which frequency it is. So if you want to get the frequency, this returns half of the frequency, I should say. This returns half of the highest frequency in use. And I should say here also, currently only valid for 8 megahertz oscillator. Okay, so how do I do the fading? Well, down here in the main function we have a test for it. We start by setting pin A on port A, pin 20 as output. This is the pin here in the I lost it here, Arduino Maker. I'm using this one here, the Arduino Maker Narrowband 1500 board with this processor. And in the, let's see, where is the drawing here? In the drawing, no, it's not in here. Is it here? Download the full pinout diagram as a PDF here. No, if it's not this one, I have this diagram, somewhere. Oh, here, the schematics in the PDF. That's what we're looking for. So here are the schematics, and if we zoom down here into the corner, we can see that this here is the LED while it's loading. Yeah, we can see here is the LED. This is the built-in LED on the board, and it's connected here to pin PA20. So that's the pin we need to configure as output, because that's the one that lights the LED. Here in the datasheet, we have the port controller and if we go to the register summary, here's the direction set. So that's the register that we mess around with, and we just change number 20 for pin 20. They explain this here in the datasheet, setting a pin as output. And then if we go back, we can use the outset register to configure the pin as to drive it high, and we just do the same thing and do pin 20, and then to drive it low, and go back to the register summary. There's another function, register out clear. This out clear value, this one, if you write 1 to it, the corresponding pin is driven low. So here I have made these functions set pin high for pin 820, and I defined this in my SAM D21 G18A pins header file. I only defined the one pin because it's the only one that I'm using, but that's this one, and I just put that port offset of the pin number. And I set the pin as high, and then a delay. Hold on, yes, I forgot. There's a loop here. So we first set it as output, and then in the main loop, what we do is we start by configuring it as 1000 cycles that we're going to go through this for loop, and because I'm using the microsecond delay, then 1000 cycles on this is just one millisecond. But because each time we run, we have to wait 1000 cycles. So here we have to delay for 1000 cycles, and then we have to delay by 1000 minus I, and I starts as 0. So we always delay by 1 millisecond on each run, and we run for 1000 times. So 1000 milliseconds is 1 second. So this should take 1 second to fade in or like turn on the LED, and that's what we want. We set it high, we delay for I, which starts out at 0. So originally we don't delay at all, and then we set the LED low, and we delay for 1 millisecond. Then we set the pin high and wait for 1 microsecond, and then we set it low and wait for 999 microseconds. Keep going until it has faded in, and I've already flashed this to this Arduino here. Now I don't see if you guys can see this. Can you see this? Yeah, here you can see the LED is fading in and out slowly. It's right there. So this should be like 1001, 1002, 1003, 1004. It's around 1 second. And also to prove that this is the actual code that's working, I have here this platform.io project open on the delay file, and I can configure this as a boot mode, and we can upload this file here, this delay one. So this is how we fade in, and while this is uploading, you can see that the light is just on. And then to fade out, we do the exact opposite. Then we set the pin high and wait for n-1 instead of setting it low and waiting for n-1. Originally, oh, success. So now the port, it's finished uploading, and you can see that it is still flashing. Can't you see this? Yeah, you can. Now, originally I wanted to do this using the PWM, the pulse width modulation. So I started trying to make a pulse width modulation library, because it's worked a lot. In this mechatronics class, we are not allowed to use any external libraries. We have to create our own ones, except if we want to use interrupts. We can use the interrupt library for C. And in the pulse width modulation, I had started looking into how it is configured in the datasheet, and there's how many steps? An 8-step process to configure anything as a pulse width modulating signal. And I was just kind of like, oof, that's quite a bit. And then I looked a little bit more into this homework assignment, and it says explicitly here using delay functions. So I did not continue further with pulse width modulation, but I had already spent a lot of time on it, so this is better. And that's how I did this. The link to the datasheet and everything will be in the description, as well as the source code. Awesome sauce.